Hi, Econ 200 students. Hopefully this is the third and final lecture in elasticity. I think by the time you've gotten through all three lectures, a little bit lengthy, I apologize, but I want to give you enough reinforcement and support so that you're really getting into the heart of the micro stuff and the more quantitative aspects of intro economics at this point. So what I want to do in this lecture in particular is go over some practice problems, some word problems, some different ways that we talk about and measure elasticities and go through the calculations, how you would approach and solve these types of problems. So just a little bit more example, that's all. And also I have reminded you of the four different midpoint formulas, although I do want to say that the midpoint formula is the same across all four. It's the same structure. You only change variables slightly. So for example, the only difference between the price elasticity of supply, price elasticity of demand calculation, and there's a lot of difference theoretically, but the calculation is that it's quantity supplied instead of quantity demanded. And that's it, you use the same formula. So students are often like, do I have to memorize all these formulas? Well, it's just one formula. And once you understand that for income elasticity, all you have to do is substitute income for price, it's just the same basic formula. We're not throwing different curves at you or different formulas out in left field. So I want you to become very comfortable with that midpoint formula as well as the general formula and knowing when to apply which formula. Basically, in a nutshell, if you have both prices and both quantities, you will use the midpoint formula. If some of that information is missing, then you're going to default to having to use the general formula. Okay. So that's my little bit of guidance. Also pay attention, I did post the lectures on utility already. I posted them out of order, so I'm not going to make any announcement about posting utility because it's already there. So go check out my lectures on chapter 6, utility as well. Maybe just one lecture. I forget if I did it all in one big lecture, if I broke it down like I did with elasticity. So hopefully you can have your handout for this one. It's the third and final elasticity handout. There is one that's blank for you to practice with, and then there's one where I have all the answers. It's the answer one that I'm going to work through today. And I do encourage you not to just memorize answers, but in fact to practice it on your own. Use that blank one, practice, and then compare the answers. Don't necessarily use it as a crutch. Make sure that you understand if you're getting wrong answers, why. Okay. So anyways, let me open up the exercise, the handout. I'm going to share my screen, obviously. And I'm going to go over here. And so here I have, in this case, this is an example on computing different types of elasticities. We're going to work through some price elasticity, some income elasticity, some cross-price elasticity. And along the way, I've reminded you here in this document a review of the important formulas that we're using. And so the general formula is that the elasticity of demand is equal to the percentage change, and this is for, beginning the price elasticity of demand. The general formula is percentage change in quantity divided by percentage change in price. We'll give you this unit-free measure, just a number. It will be positive or negative, but in the case of elasticity of demand, it's definitely going to be negative. Although by convention, just to remind you from that very first lecture I gave, that we talk about it in the absolute value sense, the magnitude of that coefficient is what we're talking about. All right, and then the midpoint formula, if you have the different P's and Q's, the midpoint formula, also called the arc elasticity formula, is change in Q over change in P times, that's a dot there that represents times, average price divided by average quantity. It's slightly different the way I've rewritten it here from what in the book. If you've learned the one in the book and you like the one in the book, by all means, the formula that's in the book will get you the same exact answers, I promise you. All I've done is just rearranged it slightly. It makes a little more sense to me when I use this shorthand here. And so to remind you what my shorthand means, that delta Q, that's the Greek letter delta, means change. Change in Q is just the difference between the two Q's. And the change in P is just the difference, P2 minus P1. You do have to be careful that Q2 matches up with P2 and Q1 matches up with P1. You don't want to do Q2 matching up with P1, for example. So you just be careful with how you label the first price and quantity and then the second price and quantity. And then average P, the bar over the top of that variable, denotes average. And so in this case, it's just, I always say halfway between them. But for some people, if you're not quantitatively aligned, if that's not how your brain works as fast as mine does. Um, in this case, you can just add the two P values together and divide by 2 and just take the average. And then same thing for Q. Add the two Q values together and take the average. Either way, halfway between them, or just take the average. All right. And now when you go down to cross price here and look, this cross price formula, percentage change in Q over percentage change in Y, it's the exact same up here, except the only thing we've changed is that the two goods are different. It's good X is the quantity and good Y is the price. So we're changing the price of Y and seeing what happens to the quantity of X. We're changing the price of Coca-Cola and seeing what happens to the quantity of Pepsi. So otherwise, it's the Q on top and the P on the bottom, both of them in percentage change form. So that general formula, it's the same. You don't have to learn 8 different formulas when you're talking about 4 different elasticities, a general and a midpoint. All you have to do is know a general formula and a midpoint formula and apply it accordingly to the different types of elasticities that you're being asked to calculate. And so again, you can see the midpoint formula here for cross price. It's the change in Q of X and change of P and Y. It looks the same as change in Q over change in P, except we're denoting that it's 2 different goods, a good X and a good Y. Otherwise, it's the same midpoint formula. Easy peasy, right? All right. Now in income, we're just going to replace price with income. I will tell you that economists use the letter Y. If you're wondering why, if you're wondering as to why that income elasticity is denoted E sub Y, in economics, we use the letter Y to denote income. The letter I. All right, well, I had a brief interruption of my Zoom, so I hope you guys are back. I apologize. I think my internet is doing weird things, but let me go back and share my screen. I'm gonna go back and share my screen, hopefully. Here we go. And there we go. So this is now, I'm gonna try and pick up where I left off. Hopefully it had recorded everything up until the point when I noticed that it went down. So income elasticity, the letter Y stands for income because we use the letter I for investment already. So that's why I write out income here, but later in my examples, I will just do change in Y, and that means change in income. So just know in shorthand, in economics, the letter Y means income, okay? So the general formula is now percentage change in Q over percentage change in income. We've just replaced price with income, same general formula that we've used for the other 2 types of elasticities, okay? Midpoint formula, same thing. Change in Q, where it would be change in P, it's now change in income, and where it would be average P, it's now average income. Only substitution, otherwise same basic idea, same basic formula. And then the same thing for elasticity of supply. Should look very, very similar to the elasticity of demand, except we've changed the Q to QS instead of QD, and that's it. Otherwise, it's the same. So these are not very different formulas. And once you get comfortable with them, with this practice I'm going to give, and go get your hands on some more practice as well. Do those practice quizzes. There's going to be a post-unit quiz coming up for both Chapter 4 and Chapter 5 pretty soon. After you turn in your homework and I post the answers, then we'll have post-unit quizzes, a post-unit quiz on those 2 chapters together, okay? 1 post-unit quiz, 10 questions to cover both of those. And then again, for the practice exam and the exam, you'll have to do more practice as well. So become really good at using these and manipulating these formulas, but don't become too good that you get lazy and you'll make simple mistakes, right? So really pay attention. All right. That being said, let's go to our first practice problem here. In the price elasticity of demand, the example is the price of the newspaper. Remember those things that our grandparents used to have? No. Price increases from $1 to $1.50, and they see that the number of subscribers falls from 50,000 to 40,000. So in this case, when I see a word problem, and this is what you'll see in my handwriting down here, my somewhat sloppy handwriting, I apologize. I do the best I can on my little whiteboard on my iPad. But what I do is I start writing as I'm reading. I jot down the important information here, organize it, and then I put it into the formula. And so in this case, price increases from $1 to $1.50. The first thing my brain registered was, oh, hey, it went up 50 cents. So I wrote down change in P equals plus 0.5, right? So there we go. Then I saw number of subscribers falls from 50,000 to 40,000. And again, my brain went, oh, hey, change in Q. My quantity fell 10,000 minus 10,000. Okay. Now notice in this problem, you are given both prices and both quantities. So in this case, you are going to use the midpoint formula. We have everything we need to be able to do that midpoint formula. So I need average price halfway between $1 and $1.50 is $1.25. Halfway between 50,000 and 40,000 is 45,000. So I wrote down average P, average Q. Now I'm going to take these numbers, plug them into my formula, which says that the elasticity of demand is equal to change in Q over change in P times average P over average Q. Not a typo. Notice the P's and Q's are flipped from each other. Okay. So the elasticity of demand is negative 10,000 divided by 0.5 times then my average P, 1.25 over 45,000. When you multiply that out, and when I put these into the calculator, I just cancel out the 3 zeros on the top and the bottom, and then just multiply 10 times 1.25 on the top, 0.5 times 45 on the bottom, do my division, and I end up with, don't forget this negative sign, super duper important, elasticity of demand, always negative. I came up with elasticity of demand is equal to negative 0.56. On the basis of that, because the absolute value is less than 1, how I interpret that, because it's a decimal, is that it's inelastic. So always put your interpretation. See, it says interpret right there. Do not forget to interpret. The interpretation part is putting that inelastic label on it. Okay? Piece of cake, right? All right, let's try another one. In this case, look at this one. Another word problem, because these are how you're going to see it in multiple choice questions, right? This is what you're going to have to do to solve some of these multiple choice questions. All right. If the price elasticity of demand, and as I'm reading this, okay, pay attention. If the price elasticity of demand for hotel rooms in Seattle is 2.5, right away, look what I wrote. I jotted down that first sentence, or even the first phrase, that introductory clause said, to me, I translated that from English into econ. ED equals negative. It's always negative, even though they're talking about it in just the absolute value sense. We always put, for our calculations, put that negative in there. Otherwise, it's going to give you a positive increase in price, which would be wrong. Okay. So make sure you put that negative sign in there, right there. And the owner of a certain hotel decides that she needs to increase rentals by 25%. Ding, ding, ding. Change in quantity. So I wrote down change in quantity, and she wants to increase positive 25%. So again, I took that, translated the English into econ, and jotted that down. The next thing I read, if the current market price is 75, P1 is equal to 75, what price should this hotel charge? So in order to solve that, this is actually a two-step problem. And I realized, okay, well, the first thing I have to figure out is, given my general formula, how much is price going to change? So the first thing I have to figure out, step one, find the percentage change in price. I have the percentage change in quantity. I have the elasticity. So the general formula, there's 3 possible unknowns at any point in time. If the general formula says the elasticity of demand is equal to percentage change in quantity divided by percentage change in price, as long as I know any 2 of those 3 things, I can solve this problem. I can solve for the third. So in this case, I know the elasticity of demand and I know the percentage change in quantity. I can find percentage change in price. Once I can find that percentage change in price, I can take my initial price and then I can either move it up or down by the percentage that I calculated. So that's step 2. I'm going to have to use the percentage change in price that I calculated to then figure out what's the new price going to be. So let's go through this in 2 steps. Step 1, right here, elasticity of demand is equal to percentage change in quantity divided by percentage change in price. I am using the general formula because I don't have all the P's and Q's. I only have one price. I don't know anything about Q1 or Q2. All I know is they want to go up 25%. So I have to use the general formula. When I plug in what I know, negative 2.5 equals positive 25 divided by percentage change in P. I can rearrange this, whatever algebra you learned, right? I multiplied both sides by percentage change in P and then divided by negative 2.5. However you algebraically manipulate this, right? It's just basic algebra, but you do have to brush up on your algebra skills maybe. When you do that, you should get -10. Notice how that negative, super important. If you had accidentally left that negative off, this would have come out and said, oh, I need to raise price. But that doesn't make sense, because to increase rentals, increase quantity, I would raise price. No, that's not going to work, right? If you raise price, you're going to lower your quantity demanded. So in this case, you are going to have to lower price, put them on sale to get more people to come. Okay. And so my finding is correct in terms of the direction. I need to lower the price to increase my rentals. I need to lower it by 10%. Okay, cool. So I need to take my original price of $75 and I need to lower it 10%. So step 2, 75 times 10% is $750. So my new price is going to be my $75 minus the $750. My new price is $67.50, which should be a 10% reduction from the original $75. And there you go. So make sure in these types of problems that you understand how to answer the question correctly. They weren't simply asking for what percentage does price have to change by. They wanted the actual new price, okay? So in this case, that's what we gave them, the $67.50. All right, you can stop this video. You can go back and rework it, whatever you need to make sure that you can do this. And again, I didn't show every single step of algebra because everybody is taught algebra or learns algebra slightly different, right? I've learned that over the years. So, but you do need to make sure that you can do these algebraic manipulations and solve for the unknown variable, the percentage change in price here. All right, so hopefully that helps. Let's move on. Let's try an income elasticity question. So in this case, again, as I'm reading, I'm writing down, I'm making little notes to myself. And you can see the little notes here on the next page where I've jotted things down. So first off, average income Spokane is 38,000. So Y1, 38,000. Notice how I've used the Y to denote income. A local restaurant serves an average of 500 meals. So Q1 to go with my income 1 is 500. Now something changes. My income goes up. So Y2 is 40,000. And as a result of that higher income, the restaurant is doing more business and they're serving 550 meals a night. So I wrote that down. Q2 is 550. So therefore I can figure out my change in quantity from 500 to 550 is plus 50. My change in income from 38,000 to 40,000 was plus 2,000. So now I have everything I need to be able to put it into my formula and to be able to solve this. And so the question asked, what is the income elasticity of demand? It didn't say interpret, but of course we're always going to interpret. That should just be your gut response. So in this case, change in Q, positive 50, change in income, positive 2,000. And so you can see I put that on the first part here. The second part is average income, halfway between 38 and 40,000 is 39,000. And average quantity, halfway between 500 and 550 is 525. And when you multiply the top, you get 1950. When you multiply the bottom, I got 1050. Of course, I canceled out the thousands on both of those. I divided by 1,000 top and bottom to cancel that out. When I did this, I got the elasticity of income as a positive 1.86. Interpret, it's just a normal good. Do not say elastic. That term does not apply to interpretations of income elasticity. Just say normal good. It's positive. Income goes up and we ate out more, okay? All right, again, stop, rewind, go back, make sure that you can work through the step-by-step of my calculations here and see what I did, how I took the information in the problem, wrote it down, put it into my formula, and solved. You're going to have some practice on the homework and then the practice exam and the post-unit quizzes as well. So, but take your time. All right, suppose Joe purchases 10 six-packs. We're looking at beer now, and same thing. We're still under income elasticity, I believe. So purchases 10 six-packs of beer, Q1, 10. When his monthly income is 200, Y1, 200. Now he gets a raise, and it gives him an extra 40. So change in Y is plus 40. His income went up 40. The new Y is 240. Because he was making 200 and 40 more is going to give him a Y2 of 240. And now his Q2 at that higher income level, he buys 2 extra six-packs now. So he went from 10 to 12. So my change in Q is positive 2. And notice I am keeping track of my pluses and my minuses. The pluses and the minuses matter a lot when we're doing cross price and income elasticity in particular. All right, so then because we have both Q's and both Y's, we can use the midpoint formula, our preferred formula. Income elasticity is equal to change in Q over change in Y times average Y over average Q. So my change in quantity is the extra 2 6-packs. Change in income is the $40 raise that he got. My average income between 200 and 240, halfway, is 220. And then my average quantity halfway between 10 and 12 is 11. When I multiply that out, I get 440 over 440, perfect 1.0, and everybody wants to write unitary. No. Notice, no unitary, none whatsoever. Okay, all we're saying here is because this is positive for income elasticities, we're just going to interpret, hey, it's a normal good. Okay, any questions? Hopefully you guys can let me know if you have any, but that's the interpretation then that goes with the positive 1.0. Because it's positive, it's a normal good. Let's move on and look at a couple cross price elasticities. I think in this case, well, at least one here. Let's do this cross price one. Apples and pears. And those are, I would anticipate, substitutes, but we'll find out. And so in this case, by the, I believe they're substitutes, but we'll figure it out when we go through the math and everything. But anyways, because the cross price elasticity for substitutes should be positive. Price of one good goes up, we should sell more of the opposite good. So it should be positive. And in fact, it is 1.3. So cross price is positive 1.3. So as I'm reading this, if the cross price elasticity demand between apples and pears is 1.3, ECP positive 1.3. Quantity demanded of apples is 3,000. So Q1 is 3,000. And we have a 4% rise in the price of pears. So I'm going to write that down. Percentage change in P is positive 4%. Okay? And that's pears. I should have put a little P on there, but that's okay. You'll see down here I did. Then we're going to see by how much will the quantity demanded of apples change in response to the change in the price of pears. So if they are substitutes, which the cross price tends to suggest it is, right, because it's positive, right? An increase in the price of pears, ahead of time, I'm anticipating that the change in quantity of apples should be positive. Let's figure it out, right? So when we use our general formula, because we only have the one Q1, we don't have a second Q, and we don't have a P1 or a P2, we're going to have to use the general formula. So the cross price general formula says that the elasticity cross price is equal to percentage change in quantity of apples divided by percentage change in the price of pears. Plug in what we know. The 1.3 is equal to percentage change in quantity of apples divided by the percentage change in the price of pears. Plugging in the 1.3 and the positive 4, 1.3 for the cross price elasticity, positive 4 for the percentage change in price, manipulating the algebra. In this case, I just multiplied both sides by 4. And so I found that percentage change in quantity of apples is equal to 1.3 times 4, positive 5.2%. So my quantity of apples demanded is going to increase 5.2%. And the question says, would increase the quantity demanded by how much? They want to know how much is it going to go up. So we're looking for that change in Q. And so in this case, if we're starting at 3,000 and we're going up 5.2%, I take my original quantity and I'm going to multiply it by 5.2%, and I'm going to find out that the change in Q, it's going to go up by 156. That should have been enough to answer the question. Increase of 156 apples. That's going to leave me with a new Q2 of 3,156. I just added that second part. The change in Q would have been sufficient to answer the problem. But also, if you said the new Q2, 3,156, that also tells me that it increased from 3,000 to 3,156. So that's pretty self-evident. That's an increase of 156. So there you go. Again, a two-step problem in this case. We had to find the percentage change in quantity, and then we had to take our original Q and adjust it either up or down. In this case, it went up 5.2%. Again, stop, pause, rewind, go over this, make sure that you can do it on your own, solve these types of word problems. This is just some examples. Not all word problems will be presented the same way. There's lots of different ways I can ask these elasticity problems. This is just a sampling of some, okay? Just to give you a taste. All right. And then lastly, I think this is the last one. Hopefully my Zoom hasn't cut out anymore on you guys, right? In this case, haircuts. If the price elasticity of demand for a haircut in Pullman is negative 0.4, so right away I wrote down ED is equal to negative 0.40. Again, no units, no percentages, no nothing, just a number. It's a unit-free number. Then by how much must the price decrease for sales to increase by 12%? Sales going up 12%, that's the percentage change in quantity. So I've got 1 percentage change, I've got elasticity of demand, I can solve for the percentage change in price that would make this happen. So put it into my general formula, which is right here. I get negative 0.40 is going to equal 12 divided by percentage change in P. Again, notice the formula. There's 3 possible unknowns: the elasticity of demand, percentage change in quantity, percentage change in price. As long as you know any 2, you can solve for the third, and that's what this problem is showing you, is, hey, I can solve for percentage change in price. In this case, I multiplied both sides by percentage change in price and then divided by the negative 0.40. Basic algebraic manipulations. Make sure using your algebra that you can do this, and you may have to do it step by step just to make sure, prove it to yourself how many steps it takes to you, right? In this case, I get the percentage change in price is negative 30. And so I would need to reduce my price by 30% in order to get a response of my sales to go up by 12%. Okay, so there we go. Another example of the general formula. So hopefully by the time we've worked through all of these, that you have a better sense of when to use the midpoint, when to use the general, and then how the different ways that we can ask you if you understand and are able to calculate these elasticities and solve problems on the basis. It's the decision making, how to guide the decision making for the firms or the consumers in this case. So hopefully this has helped. I'm going to post both the answers and the handout for you to practice the answers so that you can see all the work and compare, and you can follow along and go through several times if you need to replay this lecture. It's one of the cool things I think about online learning is in class, I only deliver the lecture once in live time. And students have to jot down and take really good notes, but sometimes they'll miss things along the way that I'm saying, but you guys shouldn't miss anything because it's all right here recorded for posterity for you. You can always go back and say, and I can do that too. I can go, hey, don't you remember in the middle of lecture 3, I said, and students will be like, oh, I think I fell asleep during that part. Well, go back and you can verify the accuracy of my statement that I did talk about that. All right. So anyway, so these lectures are for you to listen to as many times as you want and to pause and to stop and all that good stuff. Hopefully you find them helpful. And that's, I think I'm going to wrap up elasticity at this time. If you have more questions, please reach out. Do come to my office hours. Do email me, whatever needs to happen. We can schedule a Zoom meeting at a time that's mutually convenient for us. Try to be as accessible as possible for you guys. Try to help you. I'm here to help. I'm your coach. So let me know what I can do, and hope this helps. Keep studying, keep working hard, and we're going to be going on to some more good stuff coming. So, all right, I will talk to you guys later. Get working on that homework is what I would say. So, all right, again, let me stop my sharing and let me stop my